Hello, and welcome to this week's Ethical Dilemma in Science. We're going to take a look at space debris filling the sky and ask, is this an inevitable outcome of progress or possibly humans polluting beyond the Earth? So, like all of these ethical dilemmas in science, based on a recent news account, two articles that I saw from earlier in October. Billboards from space might eventually be cheaper than Super Bowl ads with a much bigger audience. Here's how companies can start advertising from the cosmos. Basically, it's a study that came out of Russia, made a lot of popular news accounts, but the idea of putting out basically kind of little clusters of satellites that would be in orbit and would produce almost like a little pixelated symbol or pixelated advertisement. So, not quite the billboard that you'd see driving down the highway where you're, looking almost like the equivalent of a TV ad, but at least at this early stage, something that would be, kind of disrupting your view of outer space. Now, when we start talking about satellites in orbit, I think back, and this predates me just a little bit, but the first satellite that was placed in orbit was in 1957, where the Soviets launched Sputnik 1. Big concern about that within the United States. There was basically a race going on to put the first man-made object into space. The Soviet Union placed it there first. A few months later, the United States was able to follow up. But since that time, we've seen an accumulation of materials in orbit around our planet. So a more recent example of something being placed into orbit occurred in 2018. SpaceX, a company built on space exploration, was testing the maiden flight of their SpaceX Falcon Heavy rocket, and they needed a payload. And so they weren't going to launch a satellite initially. And so what they did is they took a Tesla Roadster, they put a mannequin in it, dressed him up as a Starman, and then shot him out into orbit. And so you can see in the green over here, it's an orbit that kind of goes around the sun and then basically comes close to Earth at some point, and then kind of continues on along its orbit, along its path. As of October 2022, so about 4.5 years maybe, we're looking at this Tesla Roadster as having traveled 101 million miles at roughly 69,000 miles per hour. And so just another example of something being placed into an orbit. Now, the whole concept of placing an object into orbit is this idea that the rocket is going to launch from the planet, launch from Earth. It is going to be moving forward, and at a certain point, it is going to release the satellite, and that satellite is going to have some forward momentum going along with it. Without the resistance that's found in outer space, that's going to continue moving forward unless other forces are acting on it. And so on the other side over here, we can see that the momentum is going to be balanced out by the force of gravity kind of pulling this back towards it. Now, ideally, if we do this properly, if rocket scientists do the right math, we're going to have a situation where the momentum forward is going to balance out the forces of gravity pulling it down. Okay, so the idea is that if we have a situation where the forward momentum is balanced out by the force of gravity, that satellite is going to stay in orbit and continue going around the planet again because there's very little resistance outward in space. But if the rocket scientists don't get the math right, we're going to have an imbalance between the forward momentum and the force of gravity. And so if there is too little forward momentum, we're not going to have enough forward momentum to keep it out in orbit. And so the force of gravity is going to overcome that forward momentum and gradually pull that satellite back down towards the Earth's atmosphere to lower and lower orbits, ultimately to re-enter the atmosphere. And if it's a kind of small or normal sized satellite, this is probably going to burn up on re-entry. If the force of momentum is too great, the force of momentum moving forward is going to be greater than the force of gravity pulling it back down towards the planet. We're going to have what's referred to as escape velocity, and that satellite is going to kind of go off into what would be referred to as outer space, but basically leave the orbit of the planet Earth. And so the goal of launching a satellite into orbit is to place a device or place a tool in space that is going to do some type of function. And there are going to be a variety of locations in kind of outer space close to the planet Earth where we can place objects into orbit. The first of these is going to be the low Earth orbit, and these low Earth orbits, as it says, are going to be fairly low in the kind of elevation off of the surface of the planet. So we're talking about 160 to about 1,000 kilometers above the Earth. And so these satellites are often used for satellite imaging, so taking pictures of what's going on within the planet. The International Space Station is found within a low Earth orbit, and many times kind of communication satellites where they launch a series of small satellites that work together within a constellation or net or network of satellites so that they can be kind of over a region and then share the signal within them. Another type of orbit is going to be the sun synchronous orbit, and the sun synchronous orbit is this kind of whitish one that we can see kind of circling around through here. And with a sun synchronous orbit, this is going to be a satellite that's passing over the same location on Earth at the same time every day. So it's generally synchronized for either dusk or dawn, and this allows for the collecting of images at the same time over the same location day after day after day. And this is important if you want to go through and do comparisons over a period of time, look at change occurring. And then the final one that I'm going to talk about now is this geosynchronous orbit, this longer, kind of higher elevation orbit here. It's a higher elevation. It's much further out off of the surface of the planet. And in these orbits, the satellite are going to stay stationary above the same spot on the Earth. So basically what's going to happen is that they're going to be moving fast enough within their orbit that they keep up with the rotation of the Earth. And so we can see larger telecommunication satellites up here because they're able to see a much greater region of the Earth than those low Earth orbits, as well as weather monitoring satellites are often found within these geosynchronous orbits. So they can continue to provide updates on the weather that are used for forecasting to ideally warn people of hazardous weather, dangerous conditions that are developing. Okay, so if we take a look at the launch of objects into space, for a long time that was going to be done by NASA within the United States, the Russian space agencies, other governmental agencies around the world. More recently, there's been a movement towards commercial launches. So organizations like SpaceX, which I mentioned a few slides ago, Blue Origin, Virgin Orbit, as well as a whole variety of other kind of smaller companies are starting to take over the launching of satellites. And we're actually seeing that the SpaceX is delivering payloads to the International Space Station for NASA. And so the Federal Aviation Administration, the FAA, controls the launches within the United States and regulates when they can occur to minimize the impact on air traffic and make sure that there is safety in traveling above at least the United States. Now, we're also seeing a movement towards kind of smaller, in many ways, personalized satellites, starting out about 14, 15 years ago with hobbyists able to kind of build satellites. More recently, there are organizations, this is the European Space Agency, TubeSat, IOS TubeSat is another company. They're basically providing kits which allow people to design a small satellite, generally on the order of several kilograms in size. So, about the size of a decent sized box or even a little bit lower, a little bit smaller. And they will be placed into orbit for that individual. And so you could have one launch, one rocket basically going up into space, delivering a whole variety of these small satellites. Now, an example of this, SpaceX launching its Starlink communication satellites, internet communication satellites into orbit. A July 2022 launch placed 46 different satellites into orbit with a single launch. So, with all of these launches of materials into space, we're seeing an accumulation of debris that is found within orbit around the planet. Now, there are roughly about 5,000 active satellites that are functional and working right now, but there are another 27,000 pieces of debris or non-functional satellites that are in orbit around the planet that are tracked by the Department of Defense's Global Space Surveillance Network. Now, in addition to the 27,000 pieces that are large enough to be tracked, there are millions more pieces of very small fragments, debris, paint chips, maybe screws, things like that, that are still very, very hazardous to human spaceflight and satellite missions. Now, the reason for that is that these very small objects are still traveling at an incredibly high speed. So they're traveling at about 15,700 miles per hour in these low Earth orbits. And so because of that, they have a lot of inertia with them, and they will cause a lot of destructive force if they come into contact with an object. So an example of that, in 2009, a inactive Russian satellite collided with a U.S. Iridium commercial satellite, destroyed the U.S. satellite, and created about 2,300 large pieces of trackable debris and many, many small pieces of debris. And this is a concern. And so they have an entire operation monitoring kind of the space around the International Space Station. And if it looks like an object is going to be coming too close to the space station and potentially going to cause damage to it, they will try to move the International Space Station out of the way. And so if they have a capsule attached to it, they may fire the rockets on the capsule to lift the International Space Station into a slightly different orbit and move it out of the path of the potential collision. So as we can see, as we replace inactive or damaged satellites with new satellites, as we launch new satellites for new functions into space, I use GPS in my car commuting almost every day just to be able to see traffic patterns. Those are options and functions that were not available to us as recently as 5 or 10 years ago. But we're going to continue to have more and more of these objects accumulated in space, and the risk to the hazards of space travel as well as active functional satellites because of potential collisions in the future. So currently there's a 25-year lifetime for satellites, and so 25 years after a satellite has been non-functional, so after the end of the mission, it is supposed to be removed from orbit. And so that's basically a really difficult thing to do. You can't kind of go out there, pick it up, and return it at this point. We don't have that technology. And so the idea is that there would be a way in which we could deorbit these things, so pull them out of orbit, basically decrease their forward momentum, have them fall back towards the surface of the planet, and burn up on reentry. And so in September of 2022, the Federal Communications Commission, and so the FCC, as opposed to the FAA that monitors and regulates launches, the FCC, the Federal Communication Commission, basically regulates U.S.-owned satellites. And they've instituted a 5-year lifetime for satellites. And so this idea that the satellite must be disposed of within 5 years of completing its mission. Now, this only applies to satellites within the United States or operated by U.S. operators. But it basically kind of introduces a problem because we've had a 25-year ban previously, and that ban was not legally enforced, which is contributing to this increase in debris in the orbit around the planet. Now, a variety of companies have started to look at the possibility of space junk removal. And so the European Space Agency has ClearSpace 1, which is set to launch in 2026. A company in the United States, Starfish, is looking at launching what they call the Space Otter Tug, which would go around and knock satellites out of the orbit, and so that they return through burnup, through reentry. This is an example here of the LCD, the end of life services by astroscale demonstration. And this is the idea that a satellite would go through. It would have magnets associated with it. It would be able to kind of collect debris, hopefully that would have a magnetic plate, a magnetic docking plate. It would start to accumulate these things, slow down, take it into a lower orbit, and then ultimately burn up onto reentry. However, with the vast volume of debris within outer space right now, within orbit around the planet, active removal of debris probably isn't going to be enough to solve the entire problem. So with all of these objects accumulating in space and continued adding of these objects with new satellites being launched on an almost monthly basis now, how do we prevent Earth's orbits from becoming a tragedy of the commons? Now, the tragedy of the commons is a term that's been used to apply to individual access to public resources with a lack of formal rules. And so we can see this on the planet with the plastic waste that's building up in the ocean. We have plastic pollution that is basically forming these large islands as these masses of pollution kind of come together and stay together because of the ocean's currents. How do we get these satellite operators and users to act not only in their self-interest, to fulfill the function, fulfill their mission, but to think about the common good of all users? Does an international organization need to be empowered to enforce the deorbit requirements? The FCC rules only apply to U.S. satellites. The UN Committee on the Peaceful Use of Outer Space in 2010 adopted the 25-year rule so that a satellite needs to be deorbited within 25 years at the completion of its mission. But again, that only came into effect in 2010, and there are no ways to enforce it now at this point. Should post-mission disposal be a requirement for all satellites prior to launch approval going forward? Should satellites be able to deorbit themselves? And so basically, do they need to have a little bit of a fuel reserve and a thruster so that when the mission is over, when the satellite becomes non-functional, they basically fire off these rockets that put it into a lower orbit and allow for the forces of gravity to overcome the forward momentum and pull it back into the Earth's atmosphere so that it can burn up on re-entry. Now, this is a real challenge for some of those small box satellites that I was talking about, like the CubeSats and the TubeSats. They have a limited budget and a limited space that's available to them. And so if we need to have a little bit of a rocket, a little bit of fuel left over, that is added space and added expense that may break the budget for these smaller operations. Now, we may be able to develop new technologies, maybe electrical propulsion, so they wouldn't have to have fuel reserves, maybe drag enhancements, so like the equivalent of a little parachute that would slow them down and allow them to fall back into orbit. But do we need to be looking at something like that? We also need to keep in mind that the FCC rules on post-mission disposal only apply to the satellites. So the upper stage rocket bodies that are in orbit as well are regulated by the FAA as a launch vehicle. And those, in many cases, are too large to burn up on re-entry. So we need to figure out what's going to happen with those things as well. And then finally, we're looking at the development of technologies to start to clean up the orbits in outer space. But how do you incentivize the removal of that current debris? Who pays for it? Is this a common good that needs to be then done by the government of one country or the government of all countries? Is this a United Nations initiative? What types of things need to be considered for that? So thank you for listening to this week's Ethical Dilemma in Science. Please see the description below for additional information and references. Thank you and have a great week.